Now that we understood the algorithm behind quick sorting, let's go ahead and let's write the JavaScript implementation of it. For that, I'm going to go into this sorting folder. Just like for any other sorting, we have created a new file, right? In the similar way, I'm going to create a new file called quicksort.js. Okay, let me just close all these merge sort related ones. Now let's create a class here, class quicksort. Okay, now in this let's write the both quicksort function as well as the pivot function that we use for finding the pivot index in the array, using which we will divide the, we will call the same quicksort function recursively by passing appropriate values. So as part of the pseudocode I've mentioned that we will also be, along with the array that we get, we will also pass start index and end index of the array, so that we can reuse the same function, which basically represent, in the entire array that you are passing, what is the start index and what is the end index till what we need to process. Because at the end of the day, anyway, quicksort is also again in place sorting algorithm, even though we are just trying to adjust the values based on the pivot index that we are going to find. So for that, I'm going to write a quicksort function. It will basically take array and it will take two values, start and end, which basically represent the starting index as well as the ending index in the array that we get. Okay, now if we go ahead and write this, right, till what time we need to divide the array and call the same function recursively, as long as there are still unsorted values in the left half as well as right half. When we will have such unsorted values, as long as the start is less than end. Once we overlap or start becomes greater than or equal to end, that means that basically indicates that the entire array is sorted. So we don't have to continue in such cases. So for that, as part of the base condition, what I will do is, if start is greater than or equal to end, that basically indicates that we have completed the sorting process. So we will simply return ARR, which is nothing but the array of the values that we have been given. Otherwise, what we will do now, our aim is to write a pivot function which will basically return the pivot index. Based on that pivot index, again we will call the same function recursively from 0 till pivot index -1, which basically represents the left part of the array which is not sorted. And again we will call the same function recursively from pivot index +1 till the end of the array, which basically represents the right part of the array which needs to be sorted. So let's assume that we will be writing that pivot function, and which will basically return the pivot index. And I'm going to read that value into pivot index. Let's say the function name is pivot. This function we haven't written, we will be writing in few minutes. And this function will basically take the array that we have been given and the start index and end index. Okay, now based on this pivot index, we will perform the same, we will call the same quicksort function, so that we can sort the left part and right part recursively. I mean, it is the same function, right? So since you are calling the same function, it is a recursive approach anyway. So what I will do, I will simply do this dot quicksort of array, and the start index for this left submodule will always be start till pivot index -1. Similarly, for the right part of the array, the start index will be pivot index +1 and the end index will be this end. Okay, in the end, once this is done, we will simply return the sorted array. Okay, so here we haven't implemented this pivot function, so we will go ahead and write that pivot function now. So pivot function, and it is taking the array and start index and end index. Okay, now if you remember the pseudocode that I had explained for finding the pivot, we are assuming the value at this start itself as a pivot value, right? So for that, what we will do, let's say const pivot index. In the beginning, we will assume start, whatever the value we passed in the start variable itself, like a pivot index, and the value we have at that is basically, let me define this to let, because we will be updating in the later operation, and the value we have at that is pivot equal to a array of start. Okay, because in the beginning we are considering that value, that whatever the value we have at the start index is itself a pivot value. Now our job is to compare the values from start plus 1 index till the end of the array. We need to adjust this pivot value into the appropriate position. That means it will not change in the future, even in the subsequent recursive calls. Whatever the position that we are going to swap it into in the end, that is a perfect position for the value pivot. That position we will call it as a pivot index, and this function has to return that. So what we will do, and again whatever the values on the left side of the pivot index will be smaller than the value at pivot index, and all the values on the larger side will be greater than the value we have at pivot index. But one thing, just because I'm saying they're smaller and larger doesn't mean that they're sorted. They can be still random. Okay, that is something to remember. Now what I will do, I will simply start a for loop for let I equal to, will always start from start plus 1 and I less than or equal to end index and I plus plus. Now what we will do is, we will basically compare the pivot value and the value at this ith index. So if pivot is greater than ARR of I, that means whatever the value we have at ith index, if it is smaller than pivot, that means pivot is greater than the value at ith index, that means the pivot needs to go on to right. That for that what we will do, we will simply do pivot index equal to pivot index plus 1. Our job now is to swap the values at ith index and pivot index. So what we will do, we will simply do, let's say const temp equal to ARR of I. Now ARR of I equal to, we will move the value at pivot index. Pivot index. Now this ARR of pivot index gets the value of temp. Okay, by doing so what we exactly are doing is, we are trying to push all the larger values onto the right side such that all the smaller values will come on to, to the left side, but we haven't still adjusted the value of pivot into appropriate position. Now if you observe clearly, right, if you remember the pseudocode also clearly, whatever the pivot index, because we are incrementing in the comparison operation, right, in the end whatever the value that remains in the pivot index variable will be the appropriate position for this pivot value. So what we will simply do is, we will simply swap the values between start index and pivot index. So let me say const, okay, again const, let's take temporary variable, and this temporary variable we will basically take the value at start index. Now ARR of start will get the value from ARR of pivot index, and ARR of pivot index will get the value of temp. Okay, but we are not done yet. This pivot function has to return the pivot index value in the end, which is inside the variable let pivot index. So we will simply do return pivot index. Okay, so this pivot function is returning the pivot index. Based on that, again we were calling the same quicksort function from start index till pivot index minus 1, and for right part of the array we are calling the same function quicksort with plus 1 pivot index plus 1 index as a starting index till whatever the end value that we have got as a end value. Okay, by doing so what exactly we are doing, we are trying to find the pivot value in each and every part of the array, and we are adjusting it to appropriate value, and we are calling the same function recursively such that all the values inside the array will move on to the perfect positions. Okay, that's how we are actually implementing the sorting. Now let's try calling this function and see if the values are, if it is actually able to sort the array in the ascending order. For that, let's say const quicksort equal to new quicksort. Okay, quicksort dot, we need to call quicksort, and let's say we are trying to sort the values 1 minus 20, 33, 120, let's say 9, 6, 3, 1. 1 is already there, right? You can pass. Even if you have duplicates also, it will definitely work, not an issue. But just I want to show it with unique values. And it is returning the sorted array in the end, right? Let's say we are capturing it in the variable sorted array. And here in this function we will have to pass the starting value and ending value, which is nothing but starting index and ending index. That is, index will always be 0 in the array, and ending index will be the length of this one minus 1. So for that, let me just define const arr equal to this one, so that I can simply grab the length arr dot length minus 1, which is the last index in the array. Now just log it, console.log of sorted array. Okay, how will we run it? It is inside the folder sorting, right? Node sorting quicksort.js. Okay, do you see we have got all the values sorted in the ascending order? Okay, that is how we actually sort the array using the quick sorting algorithm. Okay, the main difference here when you compare it with merge sort is basically in the merge sort we are dividing the array into two halves directly based on the length of the array. Okay, but in the case of quicksort, based on the pivot index that we are getting, we are dividing it into the two arrays. That means that whatever the array modules, whatever the recursive calls that we are making, need not to have half of the elements. Okay, so that is how we implement the quick sorting algorithm in JavaScript. Okay, I hope you are also able to implement it along with me. Please remember that quicksort and merge sort are the important sorting algorithms that people might ask you, as well as these are the sorting algorithms that are actually being used internally when writing the complicated sorting logics. Okay, thanks for watching. I'll see you in the next one.